Okay, so let's have a go at trying to formally prove a Hall triple rather than trying to prove it via, like, heuristic and formal argument, right? I've written all the rules we're going to need on the right hand side here. We've got the assignment rule, we've got the precondition strengthening rule, and the postcondition weakening rule, because we're not going to be talking about sequencing or conditionals or while loops for the moment. I just want to prove this statement here. So let's first off look at this and see if it's true, right? I'm not going to prove things that I don't believe to be true. So what's it saying? It's saying that if x is greater than or equal to 0, and you add 1 to it, x is strictly greater than 0 afterwards. Sure, that seems pretty legit. If I take the number 0 and add 1 to it, it's strictly greater than 0. If I take any positive number and add 1 to it, it's still going to be positive. So this feels pretty true. So now let's actually try to formally prove it, right? So there's a few ways to tackle these sort of problems. So I write the goal. So here's going to be my proof location. I write the goal at the bottom. I'm going to work my way towards it. So one way to tackle these problems is to try and do the assignment backwards on the precondition. So you can sort of copy the postcondition, I beg your pardon, copy the postcondition up, write the assignment rule, or the assignment that's taking place, and then sort of argue what would have to be here on the left-hand side, such that if I replaced x plus 1s with x's, I get x strictly greater than 0. I mean, all that is just do the assignment the other way around. Replace x with x plus 1. This looks like I'd have to have x plus 1 is strictly greater than 0 on this side, right? This is a valid form of the assignment rule, because if you replace x plus 1 with x, you get that. Cool. So how do I get from here down to here? Well, the only thing that's different, well, the code's the same, the postcondition is the same, it's the precondition that's been modified. So hopefully this property here ought to be a stronger property than this property is. Let's write it out. X is greater than or equal to 0 implies x plus 1 is strictly greater than 0. Is this a true statement? Maybe. So if x is greater than or equal to 0, that means, what does that mean? Well, that means x plus 1 is greater than or equal to 1, and 1 is strictly bigger than 0, so that means x plus 1 is strictly greater than 0. So yes, this looks like a true implication, right? This statement here is really stronger than this one here. So we can sort of scribble that out. And then I can take this condition, this precondition here, and replace it with this stronger one to get this Hall triple here. And then we're done, right? So I put in my line numbers. This was assignment. This was logic. And this was precondition strengthening, which we usually abbreviate to precon stir, because precondition strengthening is a lot to write out. Line 1, line 2. Okay? That was one possible way to tackle the problem. How else can I have done this proof? Let's try to do it a different way. So I write my goal out again. There we go. So another way I can tackle these problems is by modifying the precondition such that it's a valid form of the assignment rule. So if we modify the precondition such that it's got x plus 1s in it, and replace it with x's, so if I write x plus 1 is greater than or equal to 0, then replace that x plus 1 with an x, I get x is strictly greater than, oh, they're not the same, I better make it like this, right? So I modify the precondition. I mean, essentially what I'm doing is the same thing as before, right? So, okay, I don't want to do the same thing as before. What else could I do? I could try and modify the precondition to be something that's logically equivalent, but has x plus 1s inside. So if I add 1 to both sides, if x is greater than or equal to 0, that's the same as saying x plus 1 is greater than or equal to 1. There we go, that's a different way to do it. So you replace the precondition with something equivalent, but it's got x plus 1s inside. So I've got x plus 1 is greater than or equal to 1. Replace x plus 1s with x's. Get x is greater than or equal to 1. Okay, so that can be my first one. That's a valid form of the assignment rule. Now I've got to work out how to get from here down to here. So both the pre and the post conditions are different. So hopefully I can strengthen the precondition and weaken the post condition to get from here down to here. Okay? So this precondition here had better be stronger. So let's write it out. If this is true, does it follow that this is true? Yes, it does, right? Because if x is greater than or equal to 0, I can add 1 to both sides and get x plus 1 is greater than or equal to 1. So that's true. Okay, so now I can replace this statement with the same statement, but the precondition swapped out. Okay, because this is a stronger precondition. Okay, preconster lines 1 and 2. This still doesn't look like this. The only way I can get from here to here is by weakening the postcondition, because the only thing that's different is the postcondition. So hopefully this postcondition is stronger, and this one is weaker. If x is greater than or equal to 1, does that mean x is strictly greater than 0? Yeah, it is, right? Because if you're bigger than 1, you're bigger than 0. And if you're bigger than or equal to 1, you can't possibly be 0. So this looks like a true statement as well. And thus, I can weaken my postcondition. So postcondition weakening by lines 3 and 4. Okay? So that's like two different ways to attack the same problem. One by doing the assignment rule backwards, and one by sort of like modifying the precondition to be something equivalent, and then doing the assignment rule forwards. Depending on the problem, one of these might be better than the other, I don't know, but that's just two different ways to solve the same problem.